Hello everyone, and welcome to another Techno Wizard show. And today we are going to be taking apart a frequency generator. See, right here you can control frequency, amplitude, that is the wavelength and the wave height, as well as an auxiliary function. But listen to this. There's a loose piece inside. We gotta get that out first before we plug it in and turn it on. Alright. To take this apart, we got here our Phillips head screwdriver and this thing up on end now, which should be the external cover. So what we really want to do is take out the screws on the side here. Start with the screws on the top, since it looks like it'll slide right out from the top here. I like to say the word here a lot, if you haven't noticed. Here, here! And if these screws hadn't been stripped, this would make this part a whole lot easier. No, they're not stripped, they're just really shiny. Don't you love not being able to see what I'm doing? Here we go. This is half the fun. Watching somebody else do a bunch of work. You appreciate hard work. You watch someone else do it all day. And on the other side we got another screw over here. Find out what's shaking around inside this bad boy. Oh, it even has an AC switch between a 115 or to 40 volts. That's pretty cool. Be used with either European or American standard voltage. Now, did I get enough screws out? Left side, yes. Oh, there's one more screw right on top here. Okay. By the way, I want to say thank you to Chris Bowden for viewing my video previously touring this lab that I'm shooting these videos in. Thank you for the helpful comments, for positive feedback. You should go and check out the Geek Group website to see where they do equipment autopsy videos, where they take covers off and see fun stuff like this. Wow, look at that. It's the old white style breadboards. This thing has got to be at least 30 years old. But yeah, let's go ahead and zoom in on some of that stuff here. Took it out, they got the old caps, resistors. And now it's zoomed up, it says WaveTech 142-001. That appears to be a diode bridge, whatnot. Get the camera to cooperate with me here. Come on, focus. But yeah, fun stuff there. Oh, and over here is a bunch of, so they all say TIP30, and they say Italy on it. It's Italiano frequency function generator. Mamma mia, Mario, Luigi, Princess Mushroom. Peach, she goes around changing her name. What kind of crazy lady is that? Go changing her name. Alright, let's see where that loose part was. Gonna treat it like an Etch-a-Sketch. See, it turned upside down and I'm shaking it around. I don't know about where it is. Come on. Fall towards the front. There it is. Good. This is why I got this thing for only $10 at the MIT flea market. Because you didn't want to power it up with a loose screw inside. But now we shall give this thing power and see what the beast can do. Well, okay, we've gone ahead and powered up our function generator. And it works. Works quite well. As you see, I'm giving you a close-up of some of these items. It is a WaveTech it gets model number N732504. See, we have the frequency, which we can adjust with this turn dial here. You can have frequency, so let's say we want to have 20 hertz. It would be 2 times 10. And we have these DC offsets here, so it's a DC output. We have trigger functions. We have our FM limits knob. Check this out. So it can give a certain range of frequency. It's pretty cool. Let's put a knob on that. Here's our power off on. Frequency modulation. If we want a sine wave, which is currently selected, sawtooth wave or square wave. And here is our, if we want to select amplitude modulation, we can turn that. This is our 50 ohm output. Notice that, well, this uses standard old BNC connectors. So I'll show you here. It's a BNC connector. It's not like for your video BNC. That's 75 ohm cable. This for like rack mount type supply stuff and the oscilloscope that I'm going to trace this on. This you want to have 50 ohm cable. It's the proper impedance for this sort of thing. Well, let's go ahead and power it up. And hey, that does something. Check it out. I just need to calibrate my oscilloscope here. And the oscilloscope, that's where the interesting stuff will happen. Okay, the rest is playing with these waveforms here. Right now it's at 1 hertz. Here's 10 hertz. That's 10 cycles per second. That just means I just need to change the how much of time passes per centimeter here. There we go. There's more with the familiar scanline frequencies that you may or may not be used to. This is some fine tuning. If we can get a standing wave. There. Ooh, that crosses over itself there. So I increase the frequency. I can tell you what frequency is. As you can tell, this is a frequency of about 50 hertz here. We'll go 60 hertz. 60 hertz is the same frequency which we have coming into the lines of our house. And on your average oscilloscope, this has a bit of a loose plug here, so I can't put my hand on it. It's me tapping the case. Again, the function generator was 10 bucks. So, this is your average sine wave. Sound and most naturally occurring vibrations are in this particular waveform. This is a two-dimensional representation of it. This distance here, from this peak to that peak, is known as the wavelength. Oh, cool. I can do like inverse amplitude modulations here. Seems pretty neat. Continuous mode, there we go. Let's increase our frequencies by a few thousand. Here we go. So, that's right. So, boys and girls, if we go from one peak to 1 week, that is a wavelength. Go from the peak to what we call the trough down here. Little hill and little valleys. And this is the, as your amplitude is how high see how the amplitude increased from 0.1 to times 1. It's really, really high. So high we couldn't even see the top and bottom of it here. Yeah, this is a little flaky. And then here at 0.1, that's only 1/10 the amplitude. And the amplitude is set to 0.7, suppose volts. Offset positive, offset negative, shifts up and down. On an oscilloscope, this midline here is 0 volts. What happens when you increase the frequency? But the time in between these peaks, which is also the same except slightly off time between the troughs. Either way can be used to measure frequency, and they'll give you the same time, just shifted by 1/2 wavelength. I'm increasing the frequency. That's 300 hertz, 400 hertz, 500, 600 hertz. There's just a bunch of squiggly lines. Starts to blend in a bit here, doesn't it? 7, 8, 900, and that is about 1 kilohertz, or 1000 hertz. So I change the modulation there. It looks kind of cool, doesn't it? Now let's shift this down by 10, and there we go. Now we're only at 100 hertz. Why is it going so fast? That's because I have to go to adjust the line frequency here as well. Well, that looks kind of cool. It's playing with different waveforms here. Look at that. It's such a frequency that the entire bar moves up and down there. Times 0.1 hertz. It's 0.0001 hertz. So the frequency here, you can just barely see it going down. You see that? At 3000 hertz. We can use the stupid thing. We can use this to fine-tune how wide our waves are. We can adjust how high and low it is to center the image in the screen. So here we have 0.1. As you see, the line straightens out, flattens out. That is, the wavelength becomes narrower because it represents a greater amount of time passing. See, we hit down here, this is just our XY coordinate. Down here, this is at 0.2 milliseconds, 0.1 milliseconds. So the more we turn this knob, the less time passes. This can do more than just sine waves. That's what we call a sawtooth wave. See how it just goes up and down like the edge of a saw blade? And it also does square waves. Square waves are essentially, this is what binary signals travel on here. Like this would be a 1, this would be a 0. And it gets translated into for example, the old-fashioned modems that you'd call in on your telephone. Well, this is how the signal would carry on the telephone. But this here, your computer would recognize only this. Okay, here's a 1. We don't really know what this middle range is here. Oh, that's a 0. Okay, now we have another 1. Okay, well, we're not quite sure. 0. Here, this is more definite. It's either 1, 0, 1, 0. As you can see, this electrical item here picks up on that. Yeah, that's pretty cool, huh? And that's fun with a sawtooth function sine wave generator. Yeehaw! Alright, thank you for hanging out with me, Techno Wizard, here on the Techno Wizard program, checking out signals, how to emit them, and how to determine what they are. Alright, we'll catch you back here next time for more science fun with Techno Wizard. I'm just going to take my wig off. I pulled my hair out. Can you believe it? I pulled my hair out. Okay, I just had to add a little wackiness in there.